For years, we have all struggled with the big ball of mud situation, complicating our software development and dramatically impacting our time to market. For sure, with great tools such as domain-driven design, we have made progress. But have we finally overcome this big ball of mud situation? Can you please raise your hand if you still continue to see big ball of mud in your work life, time to time? Oh, interesting.
To understand why the fight against big ball of mud is still far from over, we invite you to join us for a retrospective on the challenges we faced. We'll dive into what worked, what didn't, and try to figure out how to overcome what is still holding us back. So let's go back to the story of the big ball of mud.
Yeah, speaking of the devil, here's a big ball of mud in its most classic form, aka the spaghetti-style monolith. It's a very large code base where everything is intertwined, with coupling all over the place and a mix of tech and domain logic code. Some of us have tried to improve situation with hexagonal architecture, trying to decouple the technical concerns, mandatory and accidental complexity, from the domain logic code, essential complexity. Hence, the monolith has evolved from this form, big ball of mud where everything is located at one place and mixed all over the place, to this form of hexagonal monolithic application, where we put the logic at the center and the technical stuff at the border within adapters.
Does some people here use hexagonal architecture already? Yeah.
Okay, cool.
However, it just fixed a part of the problem. Because the domain tends to fall into a spaghetti design itself, due to the interesting coupling of the multiple business concerns it tries to solve. So the domains still tend to be a big ball of mud and hardly fits in someone's head. It suffers from sustainability issues and time to market also issues as well. But in 2015, I think we all received this added in our mailboxes.
Oh yeah.
Microservices. Obviously, the solution to all our problems, right? So with a lot of promises of scalability, resiliency, time to market, and decoupling, it should definitely help us to better manage the size of our monolith because it split it into smaller pieces of independent microservices.
Yeah, but the situation goes out of hand very quickly, right? I mean, the thing is, microservices are challenging. They add accidental complexities, they require new tools, new expertise to master. And very often we've been focused a little bit too much on the technical side, replacing old problems with new ones, and making complexity kind of unavoidable. Furthermore, we haven't remembered the lesson from the 90s and the distributed computing fallacies. Remember things such as the network is reliable, latency is 0, of course, and bandwidth is infinite. Despite all these efforts, we haven't solved the original problem and have become distracted. As a result, our army and bunch of microservices turn into an even worse situation. Can you see it coming? Distributed monolith, distributed big ball of mud. You know the kind of situation where anytime you want to add a new feature or something like that, you need to synchronize multiple releases across multiple microservices. Of course, this was not the original microservices philosophy, but it happened anyway because we think that microservices philosophy lacks enough safeguards against that, and we end up with situation with our domain concerns spread into multiple services very often. Fortunately, our industry has discovered since that a blue book may help us to improve the situation.
So we turn to strategic domain-driven design, seeing bounded context as key to better defining the scope and the boundaries of our services. And rule of thumb quickly spread, one microservice equal one bounded context. So we shifted from, we lied to ourselves thinking we could rewrite it in a few days microservices.
Few hours, sometimes. Yeah.
Yeah. To domain scope services that better align information system with the business. However, just as there are constants in the universe, there are also constants in software. And even with all the effort, the complexity eventually grows. The entropy is unavoidable, and the quality of the design deteriorates over time. So with time, this bounded context microservice tends also to become a less big ball of mud. So we improved the situation but we didn't completely resolve all difficulties because we scoped our services according to body context, but we forgot that we are never sure if a body context design is correct. Neither if their relationships and their boundaries are the right one. So in the end, we somehow end up with a distributed big ball of mud of smaller big ball of muds.
Sad panda. Somehow we are going in circle here. Stepping back, all this effort aims to organize our system to better manage complexity, evolution, and cognitive load. In other words, everyone now wants to modularize again. And maybe it's what issues and lessons can we learn from all this?
First, bounded context design can be incorrect. There is no way to guarantee its accuracy before testing in production. Then also, we may miss some intersection between our contexts, right? And also it's possible that the growing complexity will bring new intersection to light. But once our context has been deployed in microservices, changing the design can be really, really complicated. Somehow we forgot George Box's famous quote that all models are wrong, at least the first part of the quote. And lastly, our bounded context may not have enough complexity to draw clear boundaries. And this blurriness can be the consequence of a lack of domain understanding, even among domain experts. So we must acknowledge that before deciding on a deployment strategy. So in other words, bounded context won't save badly designed microservices. This is not a silver bullet, right?
There is no silver.
Yeah. And also, microservices are not a design strategy, not at all, but rather a deployment one. So somehow with microservices, we forgot to do software design. It's now crucial to have a separation between strategic design and deployment strategies. However, while saying that, in fact, I realized that what we are actually missing is a flexible architecture supple enough to enable iterative redesign while being agnostic of deployment strategies.
Yeah, but before saying that, let's introduce ourselves with you.
Yeah.
My name is Thomas Pierrain. I'm working in this industry for more than 26 years now. I'm now VP of Engineering in AgiCap, a European booming scale-up, a fintech allowing people to manage their cash flow situation in real time. I'm also the main organizer of the Domain-Driven Design France, DDDFR, as we said in France, meetup, where I'm extensively promoting domain-driven design and other things like such as hexagonal architecture, event sourcing, TDD, etc., among other things.
And I'm Julien Topçu. I'm VP Tech of Shodo, which is a French consultancy company specialized in domain-driven design and software craftsmanship. And I'm working in the tech industry for the past 15 years and specialized in domain-driven design for the 10 years, 10 plus years, something like that. I'm also a member of the OWASP Foundation, you may know, Application Security Foundation.
Yeah, okay, let's go to the heart of the matter, would you? Starting with an helicopter view. The Hive is an architectural pattern Julien and I have implemented and improved over the last 8 years. It's an implementation pattern allowing you to manage multiple bounded contexts within the same application.
Or some information system.
Yeah, absolutely. It all started with the concept of hexagonal architecture. Imagine a way to compose multiple hexagons within the same process. Here, every hexagon acting as a module. Can say one bounded context equal to one module, and one module is basically an hexagon, all its adapters and related tests. Imagine also having a way to scale out. We can compose, we can scale out, and split an existing hexagon from your Hive outside and create another service, another process, like here, the microservices on the right. We can compose, we can scale out, we can also scale in, because it's a fractal pattern, so it allows us to pop up a new hexagon from one Hive very easily to create and add a new monolith context whenever needed.
That's fine, Thomas, but we have seen several issues earlier. How does this pattern address them? Because mistakes will be inevitable, right? And we cannot be sure about the design before testing in production. So we need a space where we can experiment with design decisions without our mistakes costing us too much. And as you know, designing is an iterative process, so we'll need that architecture pattern to be simple enough to support frequent design changes.
Absolutely. And clearly, distributed systems are really, really expensive to modify.
Yeah, absolutely. Fixing a bad design requires modifying, synchronizing changes across multiple locations, along with the inertia and the cost of managing releases at scale.
And moreover, our development tools are not really well suited enough for refactoring across multiple services, multiple code repositories. So yes, it's complicated. Reason why the Hive pattern uses the modular monolith as the cornerstone of its deployment strategy, as it allows for reversible mistakes. Changing a module is far less expensive than to change a situation involving multiple services and multiple projects. Reason why we can leverage on our IDE and refactoring tools in that conditions for the refactoring. In other words, modular monoliths help us to better manage the uncertainty of our design, because we want to change. The question is not will it change, it's when will it change.
But still, I mean, modular monolith is not brand new, right? And we are still facing exactly the same challenges. So what's wrong?
The thing is, classical modules aren't isolated enough. It means that it's very easy for the code being part of one module in a classic application to have a relationship and to be connected with some other part of the code coming from another module. So there aren't bundled enough classical modules in classical monoliths. So reason why we need stronger isolation and we need highly bundled modules. The better we encapsulate our modules, the easier it will become to switch and to split them outside. That's because encapsulation is really gold, unlocking effortless code evolution. What is key for object-oriented programming is also crucial encapsulation at the service level, where every service acts as a black box revealing its consumers, shielding implementation details and allowing really fluent and effortless changes.
You said services, but it was module here.
Yeah, you're right. And to do so, to have better encapsulation, this is where we use ports and adapters pattern. So yes, to achieve that, low coupling and isolation across modules, we use Alistair-Coburn ports and adapters mechanism, but not with the same intention. Whereas it's a huge disclaimer here. Whereas Alistair pattern were aimed to easily switch technology without hurting too much the application code, the Hive ports and adapters are here to protect and isolate our domain logic, our hexagon here, and to make them connected and have interactions. So within the Hive, the only way a module can ask something to another module is going through these ports and adapters mechanism. And before seeing more diagrams with this, let's just remind what difference between API and SPI. API on the left side of booking, for instance, is like a driver. There are many names. So API, driver, left ports and adapter is the way we ask something to a module. We ask something to an hexagon, the main entry door. Whereas the SPI, service provider interface, SPI right side, SPI right side and driven, ports and adapter are the way a module may ask something else outside to another module or to a data store or to another services, etc. Okay.
And this is the other name of hexagonal architecture port and adapters, if you don't know.
You're right. Let's have a situation with two bounded contexts here, the booking and the search. Here we have a situation where the customer can directly talk to each one of them, going through REST endpoint and web controllers on the left side, ports and adapter. But let's see in motion a use case where they need to interact those two modules. So here a user is making a HTTP request onto the booking endpoint, which is handled by a left side adapter, API adapter, which is a web controller, the REST web controller. This one is asking something to a left side port, an API port, exposed by the domain of the booking. And it's a main entry door. It's a service interface. Ports are service interface belonging to the domain. Once the booking is doing his secret sauce, sometimes you need to ask something to the search module. And to go that, he goes through a SPI port, a service interface belonging to the booking module, which is implemented by SPI adapters, which is here an in-proc adapter, meaning it won't make HTTP calls, network calls, etc. It will just simply make method call directly talking to the search hexagon through the API port. Okay? So this is two modules, actually. We have two modules here, and every module within the Hive pattern is a set of one hexagon. All its adapters, either in-proc or real one, meaning doing networks, calling external services, and also a test suite, related test suite for this, for every module. Okay? Important to keep in mind, isolation is not only for code. Isolation also meant a lot for data. And the Hive advocates for every hexagon, every monolith context, to have its own dedicated data store. A data store may be either a database or isolated, or some kind of schema or table isolated from an existing database.
So it's great because this variation of the hexagon architecture with the encapsulation principle you just described will help us define a composable architecture style which perfectly aligns with our context map. Let me explain what I have in mind. So in the context map, we outline how we want our models to propagate between our bounded contexts using strategies such as conformist, anti-corruption layer, or shared kernel, as you know. In fact, inside this architectural pattern, these strategies will define how our hexagons will interact with each other. To illustrate that, let's consider here the anti-corruption layer between the booking and the search. Let's do a little zoom here. So in yellow has been represented the booking module. It's divided into two subparts. The hexagon here, the domain, in which you will have all the business logic, and the infrastructure, in which you will have all the adapters, including the in-proc adapter of the Hive pattern. Here you can see also in blue the search module, and I have represented the hexagon, so the domain. Here, adapters are, for the search are not needed for this particular use case. Doesn't mean the search doesn't have adapters, but we won't care about them here in that particular use case. So to illustrate the interaction using the anti-corruption layer, let's take a use case. So let's say we are inside a rail booking system and the user has selected some train from his search. So the selection here belongs to the search domain. From the booking domain here in yellow, we would like to get those trains to create the booking, right? The thing is that fortunately, the search domain exposes a get selection API to retrieve that selection. But since we don't want this hexagon to be, this bounded context to be coupled together, the booking domain cannot call directly the get selection here. It has to define its own contract, its own interface, SPI, which is, let's say, here gets trains to book. And that will be the role of the in-proc adapter to do the mapping and do the implementation of the get trains to book here and call the get selection from the search. And that in-proc adapter belongs to the booking module, right? And since internally we'll be able to retrieve the selection of the search, it will have to translate that selection into the train model of the booking. And this is basically an anti-corruption layer, right? Because of this translation of models. And since here we do that in a way, the booking domain won't be contaminated by model of the search.
So no blue within the yellow?
Yeah, absolutely. Yeah. Because this is encapsulated inside the in-proc adapter. So the in-proc adapter here acts as an anti-corruption layer. So to make things more concrete, I would like to show some code for the implementation of that use case. OK, is that big enough? Can you read in the back?
In the back?
Yeah?
Looks like.
OK. So this is a backend developed with the Hive pattern. For now, this is only a modular monolith. There are several modules here, but we won't care about annotations, composition root, and hypermeters. They are technical. But you can see here I have my context map with the booking, money, and search bounded context. And each of them is divided into two subparts, like we said, with the domain, which correspond to the hexagon, and the infrastructure in which you have all the adapters, all technical stuff.
Either in proc or real life.
Exactly. You may notice as well, I don't know if you can see that, but some files will be here highlighted in yellow. If so, it means that they belong to the booking module. If they're highlighted in blue, it means that they belong to the search module, okay? So let's go back here to the booking infrastructure. Like I said, we should have here adapters, including the classical hexagonal architecture adapters, such as the controllers, but also the in-proc adapter of the Hive pattern. We'll see that a bit later. So here we have the booking controller, which is in charge of exposing a REST API for the booking domain.
It's the first left side adapters.
Exactly, yeah.
Okay.
And the thing is, to be able to do that, you have to trigger some features on the domain of the booking.
Through a port.
Exactly.
A port. Yeah.
It do so here through this prepare booking, which is a dependency that will help it to retrieve a domain booking that we then transform to a REST resource later, but that part we don't really care. But here, prepare booking, what is it? So prepare booking is an interface, a contract. Where does it belong to? The booking domain. Makes sense because this is the API to interact with the booking domain. So who is implementing this prepare booking?
Your hexagon.
This is a domain service here, as you can see, which still belongs to the hexagon of the booking in the domain. Makes sense, right? This is the concrete implementation of our feature. But remember the use case we have seen earlier. So yeah, this is space train because this stuff is groundbreaking. You are going to the moon and so on. But anyway.
You need an anti-corruption layer.
Yeah. The thing is, if you remember the use case, we need to retrieve the selection from the search, right? But we cannot call that directly. So here we have our dependencies named get trains to book.
It's the SPI port.
Yeah.
The one you need to ask questions to the outside one.
Yeah.
Okay.
So like you said, this is an interface still belonging to the booking domain. And this contract is defined by the booking to say how it would like to interact with outside to ensure proper isolation of the booking hexagon. So who is implementing these guest trains to book? Do you have any guess? No?
In-proc adapters? In-proc SPI adapters?
Yeah, that will be the in-proc adapter we've seen in the use case. Remember, the in-proc adapter is there to help an hexagon to integrate with another one. So here we are back to the booking infrastructure because this is an adapter, right? Here I name it booking in-proc adapter just to make things clearer for the demonstration. But usually I'm qualifying it, I'm naming it after the relationship of my bounded context.
More domain-driven.
Yeah, something like this, search selection for booking. Okay? Do you have it? Yeah? So this belongs to the booking module. Here the aim is to call the search, remember, and do the anti-corruption layer. That's why it's both here, the booking domain and the search domain, right? So this is where we have our translation. But remember, it has to call what from the search? To retrieve the selection? The endpoint, yeah, which is the API of the search.
In blue.
In blue, yeah. But here I did a little change. As you can see, I don't have get selection. This is get search. Just to show you that you can, for the API of your hexagons, you can return read model of your aggregates. Because the selection belongs to the search. Search is the aggregate, selection is a sub-element here. Why I do that? Because it will avoid being too chatty between your bounded context. And chattiness can be a problem, but we'll talk about that a bit later.
So you avoid the blue kingdom, the blue bounded context to get you an object that you will be able to call. Instead, you take a snapshot of your read model out of it so that the dependency won't be...
This is the aim of the get search here.
Yeah. Okay.
So with the get search, I'll be able, I'm calling the search domain. I will retrieve that search, retrieve the selection out of it, and being able then to do the conversion, right? And here I'm converting a search train to a booking train because they don't have exactly the same model, right? They don't belong to the same hexagons. This is the anti-corruption layer.
Okay.
So to see what is implementing this get search, where is get search? You have any idea? We said that already.
On the blue side.
Sorry?
The
Sorry?
Search.
No, I mean, where is located the contract, the definition of that type? And inside the search domain here, because this is the API of the search to interact with it, right? So that's why here it's blue. And here you will see that who is implementing that contract, any ID? The search domain, yeah. So here we have a domain service which belongs to the search. So this is how we have interconnected our hexagons together. And so that was for the search domain, but you will see that the search has as well here its own infrastructure in which you have adapters such as controllers. So it means that each module will exposes its own controllers, its own adapters, its own way to retrieve the database. So this is what we call a vertical slicing, as you may know. And it will help us to be able to extract a module later, if we want, to a separate service and create a microservice out of it. Okay?
Ready to split.
Ready to split.
Okay.
Just to show you the picture back, okay, the domain, the in-proc adapter within its infrastructure of the booking module, and the search domain on the right.
Okay.
Okay, so that was the anti-corruption layer. But there's also some other relationship, remember? Sometimes we have to do some trade-off and be conformist with an external bounded context. And in that case, Thomas, let's imagine that the booking here domain in yellow has to be conformist with the search. Yeah. Can I call directly the API of the get selection from the search inside the booking domain?
No.
Okay.
No. The answer is because we need some kind of placeholder for us to be aware of where to split and what to be replacing. Because to go from in-proc situation to separated services, we need a location. And it will act, this in-proc adapter will act as a blueprint for the whole team, so that in the future when we want to split, it will be easy for us to know which code we should substitute and replace. Here we should replace an in-proc adapter with a real one.
Okay, so it means there are always ready to split. In fact, here, this junction is currently a method call, but if we cut, what it will become if we do separate services?
Let's say...
Do you have any idea? Yeah, it will be a network call, yeah, because here you will have two separate services. And you will have to modify the in-proc adapter only in that case.
To replace, yeah.
Okay, so this in-proc adapter will just do the mapping between the booking and the search, but the booking will have to define its own get selection SPI.
Yeah.
Yeah, because otherwise we have too many coupling when we would like to split later.
So we are conformists because there are selection in blue within the yellow.
Yeah, we still have the search model inside the booking, but we interact with each other through port and adapters.
Okay.
But sometimes, you know, I don't want to call external domain service, and I just want to use value object from a library, such as here, the money bounded context, which is a generic subdomain. And here, search and bookings, they want to be conformist on that library. Just to take here a bit, to do a zoom, amount and currency belongs to the money library here. Okay. I just would like to use them internally in the price and the discount of the booking. In that case, can I import them directly?
Yes, that's perfectly fine, because as soon as you don't create a new service in pink, it's just a library, and you can use it like any other library. There is no
okay, so no going through port and adapters, because there's no features on the money side.
Ports and adapters are for services and things like that, not libraries.
Okay, then it should be exactly the same thing for a shared kernel as a library.
Yeah, absolutely.
If search and booking needs comfort class and schedule on each side, they can simply import them and use them internally.
Absolutely.
But by the way, if you have domain services in a shared kernel, it's pretty likely that you have bounded contexts that haven't emerged yet. And you should know that, because it's really important that bounded contexts with domain services are implemented using hexagons. Otherwise, you will have trouble when it's time to extract this bounded context and put that in an external service, right? Yeah. You don't use port and adapters only if you use libraries or stuff like that. Okay. I think now we can say the Hive pattern is ready to embrace changes and design breakthroughs. As we said earlier, mistakes will be made, right?
Yeah.
And also, you know, business will evolve with time. So we'll do some frequent changes. And I see 4 types of changes that the Hive pattern will help us to better manage. So let's compare the situation when the Hive is used with the one where traditional microservices are used, meaning not hived. So the first problem I see is the wrong bounded context split, the wrong bounded context design. So usually it means that you have some concept that has been dispatched in the wrong bounded context. For example, here you have a pink and a blue one in the yellow bounded context. This is a mistake. But also you may have overlooked some bounded context. And the consequence of that is that maybe you have dispersed its concept, like the green one here, across different bounded contexts, because this bounded context, the green one, didn't emerge yet. So to fix that problem, we should adopt these designs, right? But the cost of change within the same monolith on the left side is not comparable to the cost of change within a distributed system. Because on the left, you will have the power of your refactoring tool on the same code base, you will gather things, and you will do a single release. On the other side, you have deployed distributed system, and you will take some part of all those things, create a new service with a hell of multi-versioning and synchronized deployment, feature flipping, and so on.
No.
We are not saying it's not feasible, we are saying that it's way more costly, right? And so I think that we all have discovered after 10 years of microservices that microservices are harder, riskier, and expensiver, especially when your design is not battle proven and when it's not tested in production.
I'm not an English expert, but expensive is not a real word, right?
This is now.
Okay.
Because I needed a word that means more than more expensive for the cost of change. But in fact, we are not saying that microservices are bad, not at all. Don't get us wrong. We are saying that most of the time people misuse. Sorry. Almost the last talk of the day, so sorry. And be aware about, is your design ready for a distributed system? And the Hive is here to help you to better rationalize when to use a modular monolith and when to use microservices. Okay, let's move to the other design breakthrough reason. You have made incorrect interfaces. Usually it means that you have made a wrong REST API. But within the Hive pattern, if it occurs, it means that, in fact, this it's not splitted yet, right? Everything is within the same place. So here it means that you will have to change this API of the blue hexagon with the in-proc adapter that connects the yellow with the blue one. And if the yellow here hexagon is conformist, maybe you will have to change that. But once again, you have your refactoring tool. This is the same code base, and you will do one single release. On the other side, it's pretty likely that you will have network between changes and a distributed release or multi-versioning hell and so on and so on. So,
yeah. And you were talking about incorrect interfaces here, but let's talk about incorrect language. Renaming things, as DD practitioner is really our bread and butter. We take a lot of time to align our software with the domain, and as soon as we improve our understanding of the domain, we want to rename. So really, the Hive has been think to allow this as much easy as possible, on daily job.
Okay. But there is also one other reason why we have design breakthroughs. And this may occur when the boundaries of your bounded context are uncertain. It means that in that case, it will be difficult to define modules, right?
Yeah.
But I may have another pattern we'll talk about later during that talk for fixing this situation. Okay. So we've seen reason for change that the Hive pattern will help us to better manage. But is that pattern ready for any change in the scale of the complexity of our bounding context, Thomas?
Yes, most def. Being able to scale our code base is one of the cardinal points of the Hive. Within the Hive, one can easily scale out or scale in. Let's see how it works in animation and stuff. Here is first scaling out is when you want to split an existing monolith outside of the modular. So here we have a Hive, and you split it into multiple stuff. So question is, how do you achieve this kind of separation? I mean, cutting a chicken is done at its various joints, right? So how can we split a Hive?
But you do that with a chainsaw?
No, no. Never tried from the chicken, but splitting a Hive is made at the in-proc adapters level. We replace in-proc adapters by real adapters one.
Meaning HTTP clients.
Yeah, for instance. Yeah, absolutely. Or using any kind of SDK you want, or messaging system you want. Here we have a Hive monolith with two modules. Three modules. Two of them are hexagons, the search and the booking, and the other monolith is the shared library, as you said earlier. One can see the in-proc adapter here on the top right of the booking, which is calling the API interface port from the search. Okay. Once you split them, you just have the only change here is that you have a HTTP client right side adapter, SPI adapter, which is calling directly through HTTP the REST API, because the search is now distributed in another microservice. Okay. So it was for scale out. Now to scale in, how does it work? We just add a new bundle context within our Hive. Money booking search. Let's say we introduce during a workshop session a new bundled context, a location one that the search can be interested in calling and playing with. So within your Hive, we are this Hive, and we introduce the new location, hexagon. So it started from this, and we just pop up a new one. And the relationship between the search and location, as same as it was between the booking and the search, is made through in-proc adapters, and that's it.
And what we can see here is that if you want those modules to become services, you know exactly where to cut. This is all the links here between your hexagons, right?
Remember the chicken. So, okay, once again, splitting the Hive monolith is really a fractal process. It means that you can start from a Hive, scaling out, and then scaling in. It's really a fractal pattern, because when you discover your domain, you improve your understanding of your domain, you may want to add new bundle context and to specify a little bit more in your code base. So we explore the why, the how. Let's see brief implementation. When to apply these patterns. So for me, one of my favorite situation for using the Hive is to gain back control out of a legacy nightmare. It's usually starting from a spaghetti sauce style big ball of mud. I've seen the effectiveness of the Hive strategy in that case many times over the last 8 years. Let's take an example here. We have a big ball of mud classic application. It involves 4 contexts, but they are not bundled contexts yet, because we initially started with a vision involving 3 major concepts, hence 3 projects that we have. And every type, enum, etc., are the different colors, and because since we have identified that they are dealing different concepts. So to Hive this, we first introduce a new hexagon within the big ball of mud legacy system. Very first, it's an empty hexagon, but in purple here for the seed suggestion domain. And we will move out of the big ball of mud legacy, extract and move, all the purple classes, enum, etc., that we have, so that we will fill this new house with all the type related that were as this kind of concern in purple. So we introduce, by the way, a new data store for this Hive, as we see earlier, because every Hive, every hexagon and bundle context must have his own data store. We do the same thing with the other, then that data, it's hived. We have extract and move, and located our types and concerns at the proper place.
But it takes time, right? It's not.
Yes, it's not over the night process. But it's like a strangler pattern. You know, you introduce a new place, a new home, for this kind of bounded context, subdomain concern, and then you migrate and you empty the big ball of mud to fill your real bounded context. Okay? After that, let's say we decide to split, and we will see in a couple of seconds why we want to split this Hive into many microservices. It's working. As you were seeing before, within the Hive, we have in-proc in red arrows here, in-proc adapters doing in-proc method calls, and here we have HTTP in that case, but yeah, that's it. We have split the Hive. Okay? So that was for the brownfield.
Yeah, so let's talk about greenfield product. Usually it means that you're starting from scratch. In that case, we strongly advise you to start with a modular monolith. It will help you to manage the uncertainty of your model. And then you will be able to test it in production and change the deployment strategy when needed. So experiment at low cost with a good time to market and then industrialize. But also, if the system scales by adding more and more bounded context, that's fine, because the Hive pattern has been thought for that, because this is a composable architecture. But even if you start from scratch with a multi-bounded context system, it will work as well, because you will test your design in production before knowing, okay, if that split is right, okay, then I can decide to put those hexagons and put that in other service or not. Yeah. And if it keeps growing until you need multiple services, also it's fine, because of the fractal nature of the Hive pattern, right? With that, it will help you to define better decoupled and isolated services, just because you have lowered the risk of overlaps between your services, because you tested the design first.
Yeah.
And in my opinion, there's also one use case which is really interesting, is that the Hive helps you to manage bounded context with uncertain models.
Not so bounded context.
Not so bounded context, yes. And usually it results in bounded context with blurred boundaries. So you know that sometimes you want from one existing bounded context create a new one from it. Did you already have seen that kind of use case? Yeah? No? No one? Yeah? No one? Yes, some people. Some. Okay. But if you do so, you would see that it might be a bit of a challenge. And this is where the model mitosis comes into the rescue. So this is an approach that will help you to differentiate an existing model into several ones according to responsibilities. And in the early stages, the new bounded context you would like to create might get entangled with the one it's trying to emerge from. And in model mitosis, this entanglement, we will contain that in a shared kernel, which is a transitional shared kernel. And it will represent the intersection between your bounded context. For now, you don't have enough complexity where you should put the concept, because it looks like it's the same thing in both cases. But as the complexity grows, you will be able to specialize the concept from the shared kernel in each bounded context, and leading to a shrinking shared kernel. Until the shared kernel fades away, it helps you to define a system with distinct bounded context with a clearer separation. If you want to learn more about it, you can scan that QR code to have to view the captation of the model mitosis talk I've made with José Chevalier during Domain-Driven Design 2023.
It's a really interesting talk, I would say. Really highly recommend.
And this is a live code, actually.
Yeah.
Okay, so to sum up here, greenfield starts with a modular monolith. Brownfield modularize your monolith the Hive way.
So we have covered the why, the how, the when use case. Let's share some insights and coming from the years of practicing the Hive in our situations. The Hive approach is extremely useful, but there are some pitfalls. There is no silver bullet, as you say. Pitfalls and challenges we want to warn you about. First is to avoid multiple teams, modular monoliths at all costs. It's really, I like modular monoliths for all the reasons that we have talked about, but having multiple teams handling the same code base may be a nightmare. If you want to foster autonomy of teams also, about their practices, about the way they deliver stuff, etc. So I highly suggest you, maybe it may be one transition architecture that is supporting before a real split, but I would really recommend you to split as soon as possible. You have
Because otherwise, you will couple the cognitive load of the teams, right? Because they will have to synchronize and so on.
Yeah. Second thing is to beware of monolith inertia. It's the situation where your monoliths, even if it's modularized in a clean way, it's going to grow, to be very large. And in that case, even with one team in charge of it, it will be complicated and painful to build, to test, to deploy, etc., because it's really tend to become too large.
In other words, don't fall back to the reason why we've created the microservices, because this is still true. I mean, and indeed, here the Hive pattern will help you to scale within the same system, so which often leads to have multiple bounding contexts. And while bounding context will help you to deal with the complexity of your model, having too many of them can be overwhelming, right? It will increase the overall cognitive load for the team. As a result, the purpose of this large multi-context system will get diluted. And many new contexts might keep getting added just because it's straightforward. It's there, it's easy to put it there, right?
Like gravity attraction.
Yes, this is almost like a law of gravity. Yeah. And over time, this creates a fatigue that will causing us to be less careful about the guidelines of the Hive pattern, and that will pretty likely create some unwanted and hidden coupling that you don't want. So just like bounded context, services are there to help you deal with your cognitive load. So don't wait too much before splitting your systems.
Yeah, absolutely. So don't wait too much. Either you have multiple teams on one Hive, or either you have a very too large Hive, split your Hive. And fortunately, the Hive has been made for that, so it's cheaper than other situations. Another challenge is to avoid chattiness between modules. Very often, if you are making too chatty interactions across modules, when you want to split, you will discover the hard way that you won't be able to split it as soon as possible. Because calling methods directly within the same process does not have the same cost than calling methods through HTTP, retry attempt, etc., etc. So you may realize, as one of our team recently, that took maybe 1 month to split something, because they need to rewrite and to rethink about all the interactions across modules. You need to think about DTO, chunking my calls, etc., and to avoid at all costs the RPC trap, RPC giving you the illusion that you can call methods on an object, but which is not here, which is elsewhere, outside of the network. So remember the network computing, distributed computing fallacies we talked about.
So that's why I talked to you about returning read model of aggregates, because you will be more aligned with resources of rest that will avoid chattiness. Yeah. But
it's like a DTO.
It's a trade-off you have to deal with.
So to avoid that, you need to think about it carefully when you code. And whenever you think about ports and adapters and interaction across modules, to think about networks, and think about networks very far away, just in case you may design your stuff properly. Or you can try this attempt that we have tried more recently with some success within teams. It's to introduce network really soon, even when you are deploying your Hive as a whole within the same process, to make network calls interaction across modules that are hosted within the same process. It allows you to leverage on the load balancing, to check that all your interaction will be working enough and ready to split, you know? So it's not an early optimization, it's really something that you may keep your promise of being able to split as whenever needed, without asking, maybe you need to take 1 month or
and
two.
Keep your mistake reversible.
Yeah, absolutely. Another pitfall is to have a hidden monolith. Your test suite may be your hidden monolith. Been there, done that, don't do that. You end up with a situation when you modularize your monolith, your Hive, fine, and then you forgot to have modularized test, and then your test acceptance suite will be intricate with all the bounded context and be full aware of lots of implementation details you don't want. So in that case, split your acceptance test and coarse grain unit test so that you will be able also to split, because one of our team was the same situation, but this time they need to rewrite the whole stack test suite, because they need to introduce stubs for every module, etc., etc. So it took them time, so split your test as soon as possible. Yes, that's it. Maybe another thing, when you split and you have a stub for one module to be tested without loading all the other modules, so you will use stub, be aware of having tests that will try to check that your stub are behaving the same thing as the real adapters, calling real systems, etc. So what we call integration point test, integration test.
So you should be doing the same thing for the infrastructure, because it's not properly modularized. You will exactly have the same problem. If you want to split, then you will have to clean up your adapters, the tests, and that can be expensive. And I say that because usually hexagonal architecture practitioners tend to focus heavily on the domain, and the infrastructure is left behind, right? So don't do that. And this is even more critical if you have multiple teams on the same modular monolith, because some part of your infrastructure, like the configuration of the OAuth report, will become like a shared platform for the bounded context modules, right? And people have to understand they have a collective ownership of the shared platform. And as you know, if the responsibility is shared by every team, it ends up being no one's responsibility. So that's why you should avoid multi-teams bounded context. Okay. And yeah, do you know what it is? Sorry?
Left-star?
Yeah?
Yeah.
So this is 2 microservices and their shared database. So this is a tweet of Matthias Veras. And you should not, and we said that already, share database between bounded contexts, right? Otherwise you will have tight coupling, and you will lose the ability to scale and evolve independently. So have a dedicated data store isolated for each. That can be a transitional architecture. If you are working on a legacy system with all stored procedures, it's okay, but make sure it won't last too long. Okay, so to conclude here, this is all the properties we have seen regarding the Hive pattern. And strategic design must be constrained by deployment concerns. The Hive shifts our focus on strategic design, ensuring that deployment strategies address the business needs instead of restricting them.
Yes, we are proposing the Hive as the missing link between strategic design and deployment strategies. And that's because being able to make mistakes at low cost and be reversible is really a sweet spot. Thanks to the Hive, we can defer our decision about deployment strategy at the right moment.
So since you validate your design more quickly, especially in greenfield product, the feedback from the production and the organization will give you heuristic on what to split and when to split. And then it's also possible now to change your deployment strategy independently from a strategic design if a new non-functional requirement arises. So because you know the Hive has this blueprint that will help you to extract a module to a separate services easily. So just to, and this is the last word, model first.
And deploy as you wish. Thank you for your attention. And have fun with your code base. Thank you.